Hi everyone, I'm McCabe Levingood, and this is our mini project 2 on water contact angles.
And I'm Gracie Redmond, and we'll be talking a little bit about the different materials that we tested today.
So first we tested a plastic material, and this was our hydrophobic example. We used my computer keyboard. This is a polymer which consists of long chains of repeating carbon and hydrogen units, so it's nonpolar and therefore hydrophobic. Because it's hydrophobic, we expect that its contact angle will be greater than 90 degrees. And then for our second example, we used a metal table. This is a hydrophilic surface, so it attracts water molecules, and metal surfaces typically have an oxide layer that is polar and can form hydrogen bonds with other water molecules, so therefore it's very hydrophilic. And because it's hydrophilic, we expect the contact angle to be less than 90 degrees.
Okay, so first up, we have a picture that we took of water molecules or water droplets on top of a plastic keyboard. So as you can see, the contact angle with the surface in most cases is much greater than 90 degrees. And this is kind of showing that that plastic keyboard is hydrophobic because it's repelling the water molecules and causing it to form this bubble. And then in the next example, our metal table, the water droplets look a lot flatter and the contact angle is much less than 90 degrees in most cases, which you can see over on the right. And that's just showing that the metal table is hydrophilic and it's attracting those water molecules, kind of forcing them to flatten down onto the surface. So now we have a video of the roll-off angle of the computer keyboard. So as you could see in that video, the roll-off angle was about 43 degrees before the water rolled off. And that has multiple factors affecting it. It kind of depends on how heavy the water droplets are, as well as like the specific surface. But as you'll see in our next example, this roll-off angle is larger than if the surface were to be a hydrophilic surface. So this is the next video. So as we measured in that video, the roll-off angle is about 33 degrees, which is a good amount less than the roll-off angle of the computer keyboard. And this is a typical property seen in hydrophilic surfaces, is the roll-off angle is a lot less than the roll-off angle in hydrophobic surfaces.
Materials typically have a roll-off behavior, and this was seen when the water droplets kind of stuck together and then rolled off of the keyboard.
And then hydrophilic materials like the metal table have more of sliding behavior, and so that was visible when the water droplets slid down the surface rather than rolled down.
To wrap it all up, we're going to talk about why these properties are useful. Polymer coatings are very common and they can be applied to a material to make it more water resistant. And then for hydrophilic properties, this can allow for metals to have greater adhesion with other polar materials, and this helps increase the durability of materials.
Thank you so much for watching.
Bye!